Welcome everyone to session 6 of the TLS series. We have come a long way in this TLS discussion, and today we will discuss an important part of it: certificates. These things are pretty intimidating at the start. Then over time, you realize that when you start putting things to use, you will understand them better. Let's begin. The ITU, the Telecommunication Union. This is the organization that gave the name X509 to the certificates. The same standard also defined the LDAP architecture, so you can now see how certificate parameters are so similar to LDAP parameters. This standard evolved and other formats of certificates were introduced, but they are not part of the scope of this discussion. We will stick to X509 for now. So what is a certificate in general? It is a container for the public key for an entity. This could be a server or a client. This entity is defined in the subject field of the certificate, which is usually in a DN format, which stands for Distinguished Name. The DN itself contains some relative DNs. The relative DNs are CN, common name, CA for country, OU for organizational unit, and some more of these kind. Apart from being a container, it also acts as a digital signature by a trusted authority. The detail about the issuer, who is usually the trusted authority, is present in the issuer DN field of the certificate. Let's dig into the signing authority for a moment. This signer or issuer can be a certification authority. You might have heard about GoDaddy, Komodo SSL, VeriSign, GlobalSign, and many others like these. It can also be a self-signed certificate, in which case it's me signing a certificate for myself. Let's get something straight here. The market out there offers so many options to you when you try to get a certificate signed. Except for certificates such as EV certificates or qualified certificates, most other names are marketing terms, so don't get baffled by them. We are not going to cover extended validation certificates, that is EV certificates, or the qualified certificates here, but you can read about them on the internet. They have a very specific definition. Someone asked me a while ago, what is a self-signed certificate and how do you know whether a certificate is self-signed or not? The technical definition of a self-signed certificate is that the issuer and subject attributes of the X509 certificate are the same. The basic constraint CA attribute of the certificate is also set to true. Hey, don't worry, I will show you how this looks in a certificate. So people may ask, the root CA, which is the top entity in any certificate chain, usually has all of the above self-signed certificate properties. So how is this different? It is really not. At some point, the root CA has also signed a self-signed certificate for itself. One of the simple differences, though in most cases but not in all, is that the key usage has signing privileges enabled on the root CA, which may not be there in a self-signed one. So next time you encounter a self-signed certificate, do some research and you should be able to tell whether it's a root CA or not. In the next session, we will discuss more about certificates and wrap up. Like the page to follow up on daily updates, share the page because someone out there is still looking for this. Get in touch if you have any questions. See you all in the next interesting session of TLS. Happy learning!